Okay, just like we've had with rectangular coordinates and complex numbers, we can have polar forms of vectors. So if we've got the standard form of a vector, so let's say it's here. Okay, so far we've talked about how far we go over, that's I, and how far we go up, that's J. Well, the magnitude, if this is vector V, the magnitude is this length, and we can talk about the angle theta that it makes with the positive x-axis. And we know this makes a right triangle, so we should really call this A for how far we go horizontal, and this is B. So we can use the Pythagorean theorem to find the magnitude, and that's the formula we've shown you. We know that cosine will be adjacent over hypotenuse, so A over the magnitude. That means if we want to solve for A, we could write that as the magnitude of V times cosine of theta. Okay, and that's just like we had for rectangular coordinates, we just called it X. So when we were talking about polar form and rectangular coordinates, we had X equals R cosine of theta. Same exact thing. We're just now calling the X our A and the magnitude instead of R. And for our vertical component, we would have the magnitude times sine of theta. So when we've had AI plus BJ, we would have the absolute value magnitude times cosine of theta I plus the magnitude sine of theta J. So we can convert this back just like we've done. So it says write the vector in terms of I plus j whose magnitude and direction are given. So our A is going to be the magnitude times the cosine of our angle. So this would be 6 times cosine of 30 degrees. And we can use our unit circle to find cosine of 30 degrees. It's square root of 3 over 2. So 6 times square root of 3 over 2 will be 3 square root of 3. And our B will be the magnitude times sine of 30 degrees. So this will be 6 times sine of 30, which is 1/2. So we'll have 6 times 1/2, which is 3. So we can write this vector as 3 square root of 3i plus 3j.